This is LSAT PrepTest 64, Section 2, Game Number 1, which is questions 1 through 6. So let's go ahead and read through the stimulus. So, an administrator must assign parking spaces to 6 new employees, RST, V, X, and Y. Okay, so RST, V, X, and Y. Alright. Each of the 6 employees must be assigned one of the following parking spaces, 1, 2, 3, 4, 5, or 6. Okay, that makes sense. No 2 employees can be assigned the same parking space. The following rules govern the assignment of the parking space. Okay, so we have 6 people. We have 6 slots. So let's number them 1, 2, 3, 4, 5, 6. And our game tells us that no 2 employees can share a spot, which means there's 6 people or 6 spots, which means that we're gonna have a 1-to-1 matching ratio. So this is just a basic single level sequencing game. Okay, so let's go ahead and take a look at the rules. So rule number 1, Young must be assigned to a higher number parking space than Togoa. Okay, so this is important, right? Because a higher number parking space means over to the right, which means that if Young is assigned a higher number parking space, then this is the relationship, right? T comes before Y on this order of 1 through 6. If you had 6 over here, then Y would be over here as well. But since we're numbering it this way, this is how rule number 1 ends up going. Okay, rule number 2. X must be assigned a higher number parking space than S. That's the same thing, right? So X must be assigned a higher number space than S. How about rule number 3? Rule number 3 says R must be assigned a higher number parking space than Y. Okay, so Y and R in this relationship. And number 4 says Robertson must be assigned parking space 1, 2, 3, or 4. So R equals 1, 2, 3, or 4. Okay. So now that we've sort of mapped out our rules, we can start making deductions, right? So the first one here is very, very obviously that rule number 1, rule number 3 can come together to form a new, combined rule. So this is if T must come before Y, and Y must come before R, this can be our new rule, right? The S, the X, this is 1 plus 3, let's call it, and then rule 2 is still rule 2, and then rule 4. Let's think about this for a second, right? Now we know that R's got 2 elements ahead of it. So can it be 1 or 2? No, it can't be 1 because it's got 2 things ahead of it. It can't be 2 because it's got 2 things ahead of it. Could it be 3? Yes. Could it be 4? Also yes, right? And so now that we've combined our rules and realized that that R can only be in 3 and 4, we can go ahead and modify our rule 4 to reflect that knowledge, right? But even if you didn't combine rules 1 and 3 first, rule number 3 and rule number 4 should have told you immediately at the very least, from the outset, that R can never be in parking space number 1. But knowing what we know now, this is our modified set of rules, right? So we know that TYR comes in this order, and R must be 3 or 4. Let's combine these rules and figure out what the possibilities are. So 1 plus 3 plus 4, right? So 1, 2, 3, 4, 5, 6. There are 2 possibilities, right? R can't be in 1, R can't be in 2, R could be in 3, R could be in 4. R can't be in 5, R can't be in 6, because that's what our rule tells us, right? So in this instance, if we combine 1, 3, and 4, if R is in 3, then we know for a fact that T and Y are in 1 and 2. If we're down here, then we know that T and Y are over on this end. We don't know what order they're in. We don't know what slots they're in. They just have to be over here, subject to this S and X relationship, right? The last thing is, well, what rules do we not, or what letters do we not have rules for? We have a rule for R. We have a rule for S. We have a rule for T. We have a rule for X, and we have a rule for Y. But we don't have any rules for V, right? So this element is an element that can do whatever it wants. And we call that a floater. And so it's just important to keep in mind that no matter what, if we satisfy these rules, we can just stick V in wherever we are, right? And so this is just the complete setup of the game. This is what the final game is going to look like. Let's actually draw this in black. And so now we can just go to the questions, right? So okay. Question 1 is just going to be your straightforward application of the rules question. Okay, so question 1. Which of the following could be assignment of parking spaces to new employees? So let's go with A, B, C, D, and E, and let's just figure it out, right? So let's start by applying this first rule, or this combined rule, I guess, T before Y before R. Okay, so answer choice A. Does answer choice A satisfy this T before Y before R? No. This violates rule number 1, and so it can't be it. Because the young Y is in the first slot here, which means that T should be before, but it's not, right? How about the next answer choice? T before Y before R? Well, yeah, T is in 2, Y is in 3, and R is in 5. Well, the question is now, right, R is in 5. Can we have that? No, because our fourth rule tells us that R can only be in 1, 2, 3, or 4, or, we figured out that R can actually only be in 3 or 4. And so this violates our fourth rule, so answer choice B also cannot be it. How about answer choice C? Does that satisfy T before Y before R? Well, here we have T in 1, Y in 2, and R in 4, so yeah, it does satisfy that rule. Okay, the next rule, does it satisfy S before X? No, because in answer choice C, X is in 3 and S is in 5, which is the exact opposite relationship of what we want. And so this one actually violates rule number 2. So it's incorrect. How about D? Does it follow the T before Y before R rule? Well, T is in 1, R is in 2, and Y is in 3. So no, it doesn't follow our combined 1 plus 3 rule. And so which means that also can't be, which means that E must be the answer. All right, so let's just verify it. So does it follow T before Y before R? Well, T is in 2, Y is in 3, R is in 4. So yes, it does satisfy that rule. Does it follow S before X? Well, S is in 1 and X is in 5. So yes, it also satisfies that rule. And finally, is R in 3 or 4? Yeah, R is in 4. And so answer choice E satisfies all of our rules, and so therefore it must be the answer. Okay, question 2. If T is assigned a higher number of parking space than S, then which of the following could be true? So now, in addition to everything we know that T is assigned a higher number of parking space than S, right? Which makes this now look like this. We take this rule and we combine it with this rule that we already have, this 1 plus 3 rule. So S before T, before Y before R, right? And S is also before X. We have no idea the relationship between X and any of the rest of this stuff, just to S. And then, as usual, V is out here just messing around. Right. Okay. So they ask us which of the following could be true, which means that obviously four of these must be false, and only one of them can be true. So let's go ahead and look at these answer choices. So answer choice A: can Y be assigned parking space number 2? No, because Y has got 2 elements in front of it for sure, meaning that the earliest it can come is parking space number 3. So answer choice A, not correct. How about B? V is assigned parking space number 5. Can we put V here? I mean V, we don't have any rules for that, right? That should be our first indication that of course this could be true. Because if it can't be true, then we would have to have a rule about V for sure. The fact that we don't tells us something, right? And so really we can just even just fill in the gaps. We can prove to ourselves. Well, let's just do S T Y R X or V and X, right? This works. So answer choice B looks very strong. How about answer choice C? T is assigned parking space number 3. Can T be assigned parking space number 3? Well, if T is assigned parking space number 3, then S is assigned parking space number 2, which means that X, Y, and R must all come. Well, actually, that's not precisely true. S can come in one of these spots, right? But if T is assigned parking space number 3, then we have Y here, and then R over here. R's got to be in one of 5 or 6. The problem is that R can only be 3 or 4, right? So if T is 3, then Y has to be here, and then R has to be over here, which means that it violates our rule. So C is not going to be our answer. How about D? S is assigned parking space number 2. Let's try that. So if S is assigned parking space number 2, then once again, you have T after it, then Y after it, and then so the earliest R can come is in slot 5, which again, the same thing as answer choice C. Cannot happen. And how about answer choice E? R is assigned parking space number 3. Can that ever happen? Well, no, because R's got 3 elements before it, meaning that the earliest it can come is the 4th slot. So answer choice E, we don't even have to draw it out to know it can't be right. And so answer choice B is the correct answer, and we proved it to ourselves by mapping out something that could be true. Alright, let's go ahead and move on to number 3. So number 3 asks us the assignment of parking spaces to each of the employees is fully and uniquely determined if which one of the following is true. So what does it mean to be fully and uniquely determined? Simply put, it just means that you can figure out exactly where everybody goes, and there's no wiggle room, basically, right? Okay, so they're gonna give us 5 things. One of these things is gonna basically fill in all the gaps for us, tell us exactly where everybody's got to go, and the other 4 are not. And so the way to tackle this is just to see if our new piece of information gives us the necessary information in order to fully and uniquely determine the positioning of everybody. So let's go ahead and take a look. So answer is A. Says that S is assigned parking space number 1. So immediately I can tell that this isn't going to work. Why? Because S comes for X, and then we have no idea where T, Y, and R are, and we also have no idea where V is. Right? The entire question of this game hinges around this element V, right? Because they can tell us anything they want about any of these 5 elements. The problem is that none of these tell us really where V goes, unless they're super restrictive about where all this stuff can go, right? And so answer choice A, definitely not restrictive enough, right? Because S comes for X, T, Y, and R is in a relationship somewhere, and then V can go anywhere. We can plug V anywhere into here, and we have no idea where it goes. So answer choice A is not going to be correct. How about answer choice B? Y is assigned parking space 2. So if Y is assigned parking space 2, then what do we know? We know that T's got to be in 1, and then we know R's got to be out here, right? We know that S has got to be before X, and we still don't know anything about V. And so we definitely can't fully and uniquely determine just from this information that Y is in 2. How about answer choice C? V is assigned parking space 3. Ooh. Well, this one immediately jumps out to me because it tells us where V is. It tells us where a floater is, right? And so now let's look at this. If V is in 3, that means where does R have to go? R can only go in 3 and 4. So if V is in 3, R must be in 4. Okay, well if R is in 4, then T and Y have this relationship, right? And these are the only 2 slots they can go in, which leaves us with S and X. And they must be in this relationship as well, right? So answer choice C looks very strong. There's no wiggle room in this answer choice. Let's just verify. Answer choice D. R is assigned parking space 4. So 1, 2, 3, 4, 5, 6. R is assigned 4. And so what? Right? We know that T and Y have to come over here. We know that S and X, and then we still know nothing about where V goes. Right? There's just a ton of possibilities. There's no way we can fill these in for sure. And so answer choice D is not going to be it. And how about E? X is assigned parking space 5. So now X is here. We know that S is before it. We know that T, Y, and R are in this relationship, and we still don't know anything about V. Like I hope you see the pattern here, right? Like we can't place V, can't place V, can't place V, can't place V, which automatically tells us that these 4 are incorrect. Whereas the 5th one tells us where V goes, and then the rest of the rules are restrictive enough that we can work our way around it, right? So answer choice C is the answer to question number 3. How about question 4? For how many of the 6 new employees is the assignment of parking spaces limited to only one of 2 possible spaces? So I mean, let's just go ahead and list out our elements again: RST, V, X, and Y. So the question's asking us, how many of these are limited to just either or, right? So immediately we know from our list of rules that R is definitely either in 3 or 4, right? That tells us that R definitely is limited to one of 2 possible spaces. What else do we know? We know that V is a floater, right? Knowing that V is a floater tells us that V can go anywhere it wants. It's not limited to just one space, right? So V definitely not one of the things that's restricted to one of 2 slots, right? Which leaves just these 4 other elements. So what have we eliminated? The fact that R is here eliminates the possibility of none, whereas V eliminates the possibility of all, right? So let's just actually reproduce our answer choices, right? A, B, C, D, and E. A is none. So because we know R is limited to one of 2 spaces, we know that A is not correct, right? Okay. So how about next? How about the next thing? Where can S go, right? So is it limited to one of 2 spots? Well, no, it's not, right? Because we can up here we were able to put S in 1, and then we could have filled in the rest of these. We didn't end up doing it, but we could have filled it in. Whereas over here, S the correct answer has S in 5. Whereas in answer choice E, we could have put S in 2 and filled in the rest of these as well. And there's just no way that we can limit it to 2 spaces, right? So S is definitely not limited. How about T? Well, we know that T is in this T to Y to R relationship. And so let's look at our possibilities, right? It can definitely be in 1, right? And can definitely be in 2, But because R limits where it can go, can it be in 3? No, because Y has got to come between T and R. And obviously it can't go after R because of this relationship, right? So T can either be in 1 or in 2. And so yes, it is limited to one of 2 spaces. And so now we can eliminate the answer that says none, or the answer that says 1 if it's there. Unfortunately, it's not there, so we have to keep going. Right? V we've already determined is not is not restricted to 1 of 2 slots, which leaves X and Y. So let's actually look at Y first, right? Because Y is very similar to T in the sense that it can obviously never go first because T is always before it. And so we know it can go second in this scenario. We know it can go second or third in this scenario, and it can't go anywhere after, right? So Y is stuck between slots 2 and 3, in the same way that T is stuck between slots 1 and 2, right? So absolutely, Y is restricted to 2 slots, which means that we can cross, now that we have 3 check marks, right? We can cross out the answer that says 2, and also, since we have only one more thing to evaluate, the maximum we can have is 4, right? Which means that you can also cross out the answer choice that tells you that 5 things are restricted to 1 of 2 slots. Okay, so now this all hinges on X, right? And so what do we have here? We have in this scenario, let's just start with this scenario, that T, Y, and R are locked into these positions, right? And so S has to come before X, so the earliest X can come is 5. It can come in either 5 or 6, depending on where V is in this scenario. Okay, great. How about down here? Well, let's actually reproduce this to make this clear, right? If R is 4, then we know that T and Y have to come over here. We know that S comes before X, and we know that V floats, right? And so once again, we want to ask ourselves, where can we put these things? Well, T and Y take up 2 of these 3 slots, which means that this S and X relationship, no matter where we put S, even if we put S before the R, the X is always going to have to come after the R, right? Because there's certainly no way that X can ever come before R, because if you put, for example, I don't know, like T and Y here, then S has to go here, or V has to go here. Right? If you put T and Y here, or maybe even T and Y in this arrangement, the bottom line is you only have 1 slot here, and it can never be X, right? Because there's always something before X that we haven't satisfied yet, right? So it looks like X is just going to be limited to 1 of these 2 slots, right? If we put S before R, then X can be in 5 or 6. If we put S after R, then X is just going to be in 6. So yes, it does look like X is also restricted to the last 2 slots of our game. And so that crosses out the answer choice for 3, meaning that 4, answer choice D, is the correct answer. Alright, let's go ahead and take a look at number 5. Number 5 says, if Y is assigned a higher number of parking space than S, in other words, if S comes before Y, then which of the following could be true? Okay, so let's integrate this into our list of rules. So in addition to being before Y, S also has to come before X, right? And what else do we know about Y? Well, we know that Y has to come before R. We know that T has to come before Y, and so this is a fairly sizable set of restrictions, and then V as usual is floating out in the middle of nowhere, and so they're asking us what could be true. So I mean it's just what's probably going to end up happening is that these letters they're going to ask us like can Y be in like 1, for example. And then you just know it can't because it has elements in front of it. That's how these questions tend to play out. Okay, so let's go ahead and take a look at the answer choice. So answer choice A. To go as assigned parking space number 1. Is that possible? Well, there's nothing in front of T, right? So we know for sure that it's not just flatly impossible just looking at it. The question is whether it works, right? So let's just actually do this. Let's just use let's just do S, Y, and R. Here, right, this chain of it. T is before Y, so we're good there. S comes before X, so we're good here. And then let's just put V in the last slot. This satisfies all of our rules, right? T before Y before R, S before X, R is in 4, and then our new rule is also S before Y, right? So answer choice A looks very strong. Let's look at answer choice B. Young is assigned to parking space number 2. Can Y ever be assigned to 2? Well, no, because it's got 2 things in front of it, meaning that the earliest it can ever come is 3rd, right? So absolutely not. How about answer choice C? R is assigned parking space number 3. That's exactly the same thing, right? Because how many things does R have in front of it? 1, 2, and 3, right? All 3 of these elements are in front of R, which means that even if you put these the earliest possible, the earliest slot that R could occupy in this scenario is 4, right? And in fact, given that R can only be in 3 and 4, we know for sure if we sort of 1, 2, 3, 4, 5, 6. If we sort of map this out, we know for sure that R's got to be in 4, right? And then because T and S are both in 4Y, we know that Y has got to be in 3, right? And these two switch off between T and S, and then X and V switch off out here, right? This is an inference that you can make even without looking at the answer choices. But if you didn't figure it out, then answer choice C should have clued you in on the idea that, hey, look, Y can't be 2 and R can't be 3. R must be 4, which means Y must be 3, right? But in any case, answer choice C, you just look by whether or not you look at it from the from our relationships, or whether you actually figure this out ahead of time, it's not correct. How about D? S is assigned parking space 3. Is that possible? No, that's not possible because Y has to be here, right? S and T switch off between 1 and 2. And for the record, the reason that this is the case is that if you put S in 3, then the earliest you can put Y is 4, the earliest you can put R is 5, and that violates a rule. So no, you can't do that. And how about answer choice E? V is assigned parking space 4. Well, is that possible? No, because R's got to be in parking space 4, right? Like once again, just to illuminate the situation, if V is 4, that means R must be 3. If R must be 3, then it's got T, S, and Y all ahead of it in 2 slots, right? And we just can't have that. So it turns out the answer choice A is the only one that works, which makes sense since that's the correct answer. Okay, and let's polish this off with number 6. If R is assigned parking space 3, which of the following must be true? Okay, so since they don't give us any new information, we must be able to figure it out just by the fact that they give us that R is 3. Well, what do we know? We figured it out over here, right? If R is 3, then by combining rules 1 and 3, we know that T and Y are in 1 and 2. Do we know anything about S and X or V? We know nothing about these guys, right? They can occupy these 3 slots in whatever order they want. So the bottom line is either this is going to be your answer or this is going to be your answer, because these are the only 2 things that we know for sure, right? And so either the answer is going to be T is in slot 1 or Y is in slot 2, and that's just it. So looking at our answer choices, answer choice A, S is assigned to 4. That could be true, but it doesn't have to be true. It must be true. It doesn't have to be true, right? And it's not something that we know for sure. T is assigned a parking space 2. That's actually blatantly false. Answer choice C, V is assigned a parking space 5. That could be true, but it doesn't have to be true, right? Again, we're looking for must be trues here. Answer choice D, X is assigned to 6. Well, it could be true, but it doesn't have to be true. Like if you put S, X, and then V here. Right, which leaves answer choice E. Y is assigned a parking space 2. Yeah, that's just this. Right, and so answer choice E is the correct answer to question 6.